Okay, on this sheet we're going to be working with problems that are dealing with perimeter and area. So on problem number 1, what they're asking us to do is to find the length, the missing length right there. They give us the width right there, and they give us the area, and we need to find the length. When we're finding area, we're going to do length times width. But if we have the area and we're trying to find one of the lengths, we're going to do the inverse operation, which is division. So the problem that we're going to solve is 216 divided by 8. So 216 divided by 8. Okay. We know 8 doesn't go into 2, but 8 does go into 21 twice. And 2 times 8 is 16. When you subtract, you get 5. You bring down the 6. And 8 goes into 56 7 times. It's going to go into it evenly. So there will not be a remainder. So that means our missing length right there is 27 inches. And that's how you find one of the missing sides of a rectangle. Okay, on problem number 2 right there, it says find the width and the area. So it's missing the width and it's missing the area, but it's giving us a perimeter of the entire rectangle. And if we know one side of the rectangle, we know the perimeter, we can find the missing sides. It's not too difficult. And how you do that is you take 9, you multiply by 2, because the opposite side over here is 9 centimeters also. So that's 18 centimeters. You'll subtract 18 from 24. We subtract 18 from 24. And when you do that, you get 6. So our missing side is going to be 6 centimeters. And that's wrong. It's not going to be 6 centimeters. That's the sum of both sides. So actually the missing side is 3 centimeters. And we can double check that just by adding all sides. And 9 plus 9 is 18. And 3 plus 3 is 6. And 6 and 18 is 24 centimeters. And now we need to find the area of the rectangle. And to find the area, you just multiply 3 times 9. And 3 times 9 is 27. That's 27 square centimeters. Problem number 3. Okay, on problem number 3, we need to find the perimeter. They're giving us the area and one of the sides, and we need to find the perimeter, find the entire perimeter of this. So, okay, if we know one of the sides of a rectangle and we know the area, we're going to do the inverse operation just like we did on number 1. So that would be 196 divided by 14. And don't let the double-digit divisor scare you, because it's just the same way as we do with the one-digit divisor. And this isn't a very large number, so we should be able to work through this. We know 14 will go into 19 one time. 1 times 14 is 14. When you subtract, you get 5, and you bring down the 6. Now we're trying to figure out how many times 14 will go into 56. We know it wouldn't go 5 times. That'd be too many. It wouldn't go into it 5 times, because 5 times 14 would be 60, close to 60 something. So let's go ahead and go with 4. Looks like we have a square there probably. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5. So it's exactly 14 yards is that side. And if we're trying to find the perimeter, it turns out it's a square. We could kind of tell that by looking at it, but we just had to go ahead and do the math just to prove it. Since it's a square, instead of doing a bunch of addition, all we need to do is multiply 14 times 4 to find the perimeter. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. So 56 yards is the perimeter. Put P equals 56 yards. Box that in, because that's what we're trying to find out. Okay, let's go ahead and look at, right up here, look at number 4. Okay, on number 4, it says a small or a sandbox is shaped like a rectangle its area is 48 square feet. The side lengths are whole numbers. What are possible dimensions of this sandbox? Do all possible dimensions make sense? And to solve this problem, we're basically going to have to find all the factors for 48. So, and how I like to do that is go ahead and make a T-chart. And basically, we're just going to write down all the factors of 48. You know, when you're making when you're trying to find the factors of a number, every one is going to have 1 in itself. 1 times 48 equals 48. We can go ahead, and the next thing I like to do is see if it's divisible by 2. And if it's an even number, we know it is. So that's 2 times 24 equals 48. 24. It's just ugly 4. Okay. Then I go ahead and try 3 out. And 3 times 16 equals 48. And I know my 4 facts pretty well. So 4 times 12 is 48 also. And the last factor for 48 that we're going to use is 6 times 8. We know it's 48. So in the question right there is asking, do all possible dimensions make sense, and explain. Okay, and we'll look at the 1 by 48 right there. 1 by 48 doesn't make a lot of sense. That would be just like the tiles on the floor are 1 foot. That'd be just like 48 of these tiles in a row. That would be a sandbox. And that really doesn't make a whole lot of sense. And even a 2 by 24 would just be a 2 foot wide sandbox by 24 foot long. And that doesn't make a whole lot of sense either. Probably a sandbox that we would use would be a 6 by 8. That's a little bit more of a square shape, and seems like it would be make more sense for a sandbox. Okay. And problem number 5. The length of a garden is 25 feet. Okay, what must the width of the garden be in whole numbers of feet so the area is greater than 200 square feet but less than 300 square feet? So, I'd like to draw a picture for that. This is my garden, and 25 feet is the length of it, and we're trying to figure out a width that is still going to have an area between 200 and 300 square feet. And just by looking at it really quick, I can tell that, you know, I like to multiply things by 10. I always like to try that out. And 25 times 10 is 250. And that falls right in the center of our 200 and 300. So that's the one we go with. Probably 10 foot width. So if we had a 10 foot width, the area of our garden would be 250 square feet, and that really works well. Let's go ahead and look at, in 6 through 9, find the missing dimension. So it gives you the area on a side, and it's once a length. On the number 7, it wants you to find the area, and it gives you one of the sides and the perimeter. And in number 8, it wants you to find the width, and it gives you one of the sides and the perimeter. Okay, question number 9. Okay, find the perimeter of a rectangle with a 9 millimeter width and an area of 270 square millimeters. And it's saying draw a picture. We'll draw a picture real quick. Okay, but I know I'm going to be using the inverse operation that I normally use for my finding my area, because it has the area already. I'm just trying to find one of the sides. And so what I do, that'd be 270 divided by 9. And that's a pretty simple problem. You pretty much it's one of our facts. We know 29 goes into 27 3 times, and it goes into it evenly. So when we subtracted, it would give us 0, and 9 goes into 0 times. So our answer is 30. It goes into it, or our missing side is going to be 30 millimeters. That's going to be the top side. and this side is 9 millimeters. Okay, let's go ahead and look at the next page. Okay, on problem number 10, it says Greg built a picture frame shown at the right. It has a perimeter of 50 inches. How wide is the picture frame? And if you look at the picture, it shows the length of one of the sides, so you should be able to figure out the length of the other side. And in question number 11, Greg covered the back of the picture with a piece of felt. The felt covers both the picture and the frame. What is the area of the felt? And that's even an easier question, because you'll have your length and your width. Okay, problem number 12. James has a goal to read 2,000 pages over the summer break. So far he has read 1,248 pages. How many more pages does James need to read to reach his goal? Problem 13. The area of the tabletop is 18 square feet. The perimeter of the same table is 18 feet. What are the dimensions of the tabletop? A, 6 feet by 3 feet. B, 9 foot by 2 feet. C, 10 feet by 8 feet. Or D, 11 feet by 7 feet. Just remember, both of them have to, the perimeter and area both need to equal 18. Okay, problem number 14. Corbett used 24 square tiles to make a rectangle. The perimeter of the rectangle is 20 units. What would be the perimeter of the other rectangles Corbett could make using only these 24 tiles? How do the area of the rectangles compare? And explain. And what I did is I drew a little blue rectangle down here, and that's supposed to signify if we was to lay out all the tiles end to end. So it's basically going to be 24 by 1. 24 tiles by 1. And if I was to look at that, I'm still going to have the same area. This area is still going to be, write it over white, maybe if I can get the white. Okay, it's still going to be 24 units, or square units. Okay, because it's the same tiles, and 24 by 1, 24 times 1 is still 24 units, but my perimeter is going to be different. Okay, because if you add up all the sides, 24 plus 24 plus 1 plus 1, that would equal 50, because 24 plus 1 is 25, and 25 times 2 is 50. So my perimeter, P, is going to equal 50 units. 50 units. So there's a significant difference. Originally, he built his 24 tiles. He did 1, 2, 3, 4, 5, 6 by 4. 6 by 4, and the perimeter ended up being 20 units, and he had an area of 24 square units. I did the same 24 square units, but I laid them out end to end and ended up having a longer perimeter. Let's look at problem number 15. Formulate a plan. Amy and Zach each have 24 feet of fencing to make a rectangular pen for their garden. Amy makes her pen 6 feet long. Zach makes his pen 8 feet long. Whose pen has a greater area and how much greater? So we got two questions there. We need to make sure we answer both the questions. And we'll go ahead and we'll work on Amy's first. So on Amy's pen is 6 foot long. I'm going to draw it right here. It's 6 foot long. And if one side's 6 foot, the other side's 6 foot, so that's going to be 12. And that's basically going to be 12 feet for the other two sides here. So basically that means her pen is a square. It's 6 foot by 6 foot. Okay, if I add up 6 plus 6 plus 6 plus 6, it's going to equal 24 feet. So If I want to know the area of her pen, though, it's going to be 6 times 6, which is 36. 36, and that's going to be square feet. Square feet. Let's go ahead and look at Zach's pen. Zach's pen's more of a rectangular shape. It's 8 foot. Okay, and if it's 8 foot on top, that means it's 8 foot on the bottom. And 8 foot plus 8 foot is 16 foot. And that's only going to give us another 8 feet for the sides here. So that means the sides are going to be 4 foot. So the area of Zach's pen would be 8 times 4, which is 32. That's square feet. So we can see that Amy's pen ends up having more area than Zach's pen, and it looks like it's by 6 square feet. So Amy's pen is 6 foot larger than Zach's pen. Problem 16. Nancy made a table runner with an area of 80 square inches. The length and the width of the table runner are whole numbers. The length is 5 times greater than the width. What are the dimensions of the runner? Now that's kind of like a little bit of a puzzle there we need to solve. Usually table runners are a little bit longer and skinny. So, it's going to be, and we can tell it's going to be longer and skinny because it's going to be 5 times longer than the width. And we have the number 80 right there. We have the number 80. So if I think of some of the factors of 80, the table runner could be 80 inches by 1 inch. So that would just kind of be an odd shape. And it would actually be 80 times longer. So that doesn't really work out. But I could go with, say, 40 foot by, let's try 20 foot by 4 foot, 2 and 4. Yeah, that's going to work out. So I'm going to go 20 feet, or I'm sorry, 20 inches. 20 inches by 4 inches. Okay, and that works out because 20 times 4, 2 times 4 is 8, so that's 80 square inches. And how many times is 4 going to 20? 4 times 5 is 20. So that works out. So 20 is 5 times greater than 4. Okay, I need you to go back and go ahead and do all the other problems that are highlighted in yellow.